In this video, we study about rational expressions. We discuss these 5 topics: domain of an algebraic expression, and simplifying rational expressions, add, subtract, multiply, and divide rational expressions, and simplifying complex fractions and simplifying different quotients. So let's start with the first one. In this, we discuss a domain of an algebraic expressions. So before we talk about algebraic expressions, let's talk about the 4 different types. So we can start with the first we define what we mean by a function, what we mean by a domain. So a domain of an algebraic expression, so in this case a function, can be written as x such that fx is defined. So we're going to find all the values for which the function or the expression is defined. And then you can see that what we get is a set. So this is a set. This is a set. So that means we can use a set notation most of the time. So let's look at a simple example. So let's say we have, so let fx equal 3x minus 1 divided by x squared plus 1. And if you look at this expression, so you can think of what values you can plug in, and you can see that the denominator never becomes 0 because x squared plus 1. So you can see that this never equals to 0. So that means actually in this case numerator does not create any restrictions. So that means you can plug in any value for these functions. That means the domain is all real numbers. So domain, we can use the curly D. So domain of f is what we can say is set of all real numbers. So set of all real numbers. So set of all real numbers. So that's the domain. Since, you can say since, this is the argument, since x can be any real number, since x can be any real number. Because you can see that there are no division by zeros. So no division by 0, because that's what we kind of worry about. No division by 0. That's one thing we worry about. There's another one when we talk about root. Okay, so let's try to, so this is how we kind of like, look at a problem. You can see that it's not that difficult. It's a very simple idea. So let's look at those 4 different types one by one. So we're going to start with the first type. That's what we call the polynomial. So the first type, which are polynomials. So polynomials are the most innocent functions in mathematics. So they behave very well. So let's talk about that first. So what is a polynomial? Let's say I'm going to say px. So polynomial means just a number and x to an integer power, like positive integer power. And then there's another number x. You subtract the 1 by the power. So you start with a positive integer power and then you subtract every time 1. And then so it goes like that, and then you end up with cx plus d. So we assume that n is a positive integer or 0. So that's an assumption. So we assume that n is a positive integer or 0. N is a positive integer or 0. If it is 0, you just get a constant. But that's a special case. So, and you can see that there are no, because n is a positive integer, so that means there are no divisions now. There are no divisions and there are no roots. There are no square roots, because n has to be a fraction in this case. So there are no roots, there are no divisions. That means you can plug in any value here. So that means if you have a polynomial, domain is all real numbers because there are no divisions or roots. So that means domain of a polynomial Domain of a polynomial is simply a set of all real numbers. The set of all real numbers. So this sometimes we write as curly r. So this is another notation. We write actually script r. We normally call this script r. So we write a script r for set of all real numbers. This is simply negative infinity all the way up to positive infinity. Also, if you graph this, this is all real numbers. So that means you're gonna draw a line, and then it is going from negative infinity to all the way to positive infinity. So the set is everything. So that means it is everything in between. So you can highlight it like that. So these are the three ways, actually four ways, to write the solution for polynomials. So a set of all real numbers, script r, or negative infinity to infinity, or just draw the whole line. That's the first type. So let's look at the second type. So second type is we can talk about the radicals. Radicals have two types. So so the second one, or part B, we can say radical. So radicals. Radicals are two types. So I'm going to call first type the type 1 radical. So type 1 radical. So you cannot find this specification in books. So this is something I discussed because it's much easier to do it this way. Type 1 radical. What are the type 1 radical? Like for example, y equal square root, not the square root, root n, y equal a root n, but we assume that n is a positive integer. N is a odd positive integer, is a odd positive integer. Odd positive integer. Odd positive integer. So when you have odd positive integers, like for example, like things like 1 and then 3, 5, 7, like that. Those are the odd positive integers. So so in this case, we can see that x can be anything. 0, negative, positive. So for all the numbers, this is valid. For example, cube root. If you look at the cube root, you can take cube root of any number, positive, 0, or negative. So that means in this case, x can be all real numbers. So this one is defined. This observation, you can see that this is defined for all real numbers. For all real numbers. That means the domain for type 1 radicals, the domain of type 1 radical is all real numbers. So script r. So that means the easy way to think about it, this is like polynomials. That's how you can think. It's like polynomials. Like polynomials. There are no problems. You can plug in anything. Good. For all real numbers. So let's look at the second type. This is what we call the type 2 radical. So type 2 radical. So what's a type 2 radical? It's y equal x root n. Here n is an even positive integer. N is an even positive integer. Earlier it was an odd positive integer, now it's an even positive integer. That's the difference. Even positive integer, earlier it was an odd positive integer. So for example, so the numbers can be 2, 4, 6, 8, things like that. But these you have to be careful because you can see that these, like for example, think of square root. So if you think that means n equal 2 means the square root. So so you can see n equal 2 means the square root. So we have x square root. This n equal 2. We don't write 2. It's the square root. So you can see that when it's a square root function, it's only defined for either 0 or positive. So that means the domain is restricted now. You cannot plug in a negative value for this one. So that means, so if you write a few examples like this, so we can say y equals square root x, or y equal sixth root, like this. So like even like in large roots, like let's say x going to 10 or 12, like that. Okay, so those are the type 2 radicals. In this case, domain is restricted, is only the values are greater than or equal to 0. X has to be greater than or equal to 0. So we can have the domain. So domain of type 2 radical is so x such that x greater than or equal 0. So if you use the interval notation, this also you can write as 0 to infinity. And then if you draw the line, so what happened? So it is it can start with 0 and then go to the right. So start with 0 and go to the right. So that's the domain. So this is 0. So those are the the 3 ways to write the domain for type 2 radicals. So let's talk about the next one, the rational expressions. So let's see the rational expressions. And we normally call the rational function. Rational function. So what's a rational function? So when you have the ratio between two polynomials, so if you write Rx, which is a ratio between two polynomials. So the ratio between those are two polynomials. So you call this a rational function. It's called a rational function. So for example, these are rational functions, like 1 over x is a rational function. 3x minus 1 over x squared minus 1 is a rational function. Maybe 2x over x to the fourth plus 3 is a rational function. So those are rational functions. So what you need to worry about in these cases, we need to look at the domain, because we need to avoid the division by 0. So that means if it's a rational expression or rational function, so the domain of a rational function, so like that, is simply you can avoid the values that makes the denominator 0. So you remove the values that makes the denominator 0. So we do not need to worry about the numerator. So just the denominator. You remove all the values that makes the denominator 0. And then we have a special case. Sometimes what happens, those px or qx may not be polynomial. It can be something else. It can be some root functions. So in that case, we call those are fractional expressions. So we're going to say quotient of two algebraic expressions, quotient of two algebraic expressions, quotients of two algebraic expressions, like with some like roots and some kind of other functions. So quotient of two algebraic expressions is a fractional expression, just a new name, fractional expression. So we don't necessarily say polynomials, or we don't say rational functions. We say fractional expressions. So for example, something like this. So let's say we have x plus 1 square root divided by x squared minus 2. So that's a fractional expression. So not polynomials. Or like 1 over x plus 3 squared. So those are what we call rational expressions. Not the rational expressions, the fractional expressions. So now when you want to find the domain, you have to think about all those different cases. So so we can think about all the other 3 types in this case. So the domain is the intersection So domain is the intersection of those three types. The other types that we discussed are those three types. There are three types. It can be rational expression, or it can be a type 1 or type 2 radicals. Okay, so let's look at some examples to make sure that we understand the topics. So we will start with this example first. So let's say find the domain of each expression. Find the domain of each expression. So we can start with the first one. Let's say we have 4x3 minus x plus 3. So that's the expression we have. And you can see that this is a polynomial. So that means we can plug in anything for this one. So you can say this is a polynomial. So that's the argument. This is a polynomial. This is a polynomial. So a special word here. So the domain is all real numbers. So the domain is all real numbers. All real numbers. All real numbers. Let's look at the next one. Part B. How about 2x plus 3 square root? So you can see that this is a type 2 radical. So this is a type 2 radical. Type 2 radical. So you'll be careful with this one. So the condition is whatever you plug in here has to be greater than or equal to 0. That's the only condition. So 2x plus 3 has to be greater than or equal to 0. So that's the only condition. Now what we're going to do, we're going to simply solve this one. So this is not that difficult to solve. So we're going to start with 2x plus 3. So we solve this like the way we are solving an equation, but you have to be careful when you divide. So the first thing to do is move the plus 3 to the other side. That means you subtract 3 from both sides. So we can write this one as 2x. If you subtract 3 from both sides, it's going to be negative 3. Next, what we can do, we can isolate x, so we can divide by 2. If we divide by 2, x greater than or equal negative 3 over 2. So this says the condition. So it says that x has to be, it should be bigger or equal to negative 3 over 2. So domain equal x such that we can just copy this result here. So that's one way to write it. Just copy the condition here. Oh, this is actually equal to this, like another solution. We don't write all of them. So like sometimes we write the first version. That's what we normally call the set builder notation, or sometimes we go with the inequalities. We go with the interval notation. So this interval notation. So we put the number, and this is x is bigger. Then we go to the larger side. As I go to infinity. Also, we can graph this solution. So that's the interval. This is a bigger. That means bigger means right. Smaller means left. So we're gonna start with the value. So this is the negative 3/2 and go to the large side. That means to the right. Okay, that's infinity. So that is the graphical version. So that's how we write the solution for this problem. So let's look at the next one. C. So let's say we have 1 minus 5x to the cube root. And you can see that this is a type 1 radical. So this is a type 1 radical. Type 1 radical means they behave like a polynomial. So that means the domain is all real numbers. So the domain is the set of all real numbers. The set of all real numbers. Good. Um, so let's look at so set of all real numbers. So part D, let's look at a rational function. So let's say we have x squared minus 4 divided by x squared minus x minus 2. So this is a rational function. This is not a fractional expression, because you see those are both are polynomials. You can see these are polynomials. So this is a what we normally call the rational function. So when you have rational function, the theory says that we only need to worry about the denominator, just the denominator. So we are not going to factor or anything. Just look at the denominator, and you're going to make sure that you can avoid dividing by 0. That means we're going to remove the zeros from the denominator. That's the only thing we do. So that means the domain is simply x such that whatever the values that makes the denominator 0, we're going to remove them. So I'm going to make sure that the denominator is not equal to 0. So the not equal sign is the important one here. And we only pick the function from the denominator. So now what we do, normally we actually set this equal to 0 and figure out what values that makes this one 0, and we can remove them. So we can do it here. So we say, okay, so we're going to set this equal to 0. So we're going to find all the fault values. To do that, we're going to factor this. So we're going to factor this. This is easy to factor. This is x minus 2 and x plus 1. Those are the two factors. Now we're going to set each factor equal to 0. Or x plus 1 equal to 0. So this says x equal to 2. And then this says if you subtract 1, x equal negative 1. So those are the two values that makes the denominator 0. That means we're going to say x such that x not equal to 0 and because both can be, and x not equal, and then x not equal to negative 1. So those are the two values that we need to remove. So that's one way to write the solution. The other way to write the solution, we can use the interval notation. So if you use the interval notation, what's going to happen, you can write this one as, so we have to remove two values. So how to remove two values? We start with negative infinity, and then stop at the first value, which is negative 1, and then like a open, that means open, and then put a union, and then start at negative 1 again and go to the next larger value, in this case 2, and open it again, and then put the union, and then start at 2 again and go to infinity. And you can see that when you write it, this what we do is we remove the here we remove the negative 1, here we remove the 2. So that's how you remove two values or any number of values, but since we have 2, we did it like that. So, and if you look at the graphical notation, and you can see it's very similar after we have this first version. So we're gonna first remove the values. So we're gonna say open dot at negative 1 and then open dot at 2. So this is negative 1 and 2. Now we can highlight the rest. So that means, so this is one part, and we highlight in between. Also we highlight after. And then you can see this is negative infinity, this is infinity. So this is the graphical version of that. So you can write any of these versions unless the specific one is requested in the exam. Okay, let's look at the next example. So next we have, this is E, we have 1 minus 3t square root divided by, let's say, t squared plus 4t plus 4. And then you can see that because the square root sign, this is not a rational function. This is because there's not the top is not a polynomial. So this is what we call the fractional expression. Fractional expression. So what we're gonna do, we're gonna consider the cases we considered earlier. For example, we can look at the numerator and denominator separately. So from the numerator, that means the top, from the numerator what we get, so we can see that this is a type 2 radical. So this is a type 2 radical, and we know how to solve type 2 radicals. We're gonna look at what is inside, and we're going to impose the condition that the inside function has to be greater than or equal to 0 because this is square root. And then this is very easy to solve. So we can see we're gonna leave 3t on this side and remove 1, so they subtract 1 from both sides. Now you have to be very careful. We have to divide by negative number. So when you divide by a negative number, what will happen? You're gonna switch the direction of the inequality. If you divide by negative 3, it's going to be t. You can switch the order. It's going to be negative 1 over negative 3. So right after you divide, switch the direction of the inequality. Now this you can simplify. This is just 1/3. So that means, so what this says that t is less than or equal 1/3. So this is one way to solve this problem. Let's discuss another way to solve this problem. The other way to do this is you can actually, so we can start with 1 minus 3t greater than or equal to 0. So the next step is we're going to move this term to the other side. So do that, we add 3t to both sides. So that's another way to do it. So we add 3t to both sides. The easiest way to think about it, if you move a term from one side to the other side, is switch the sign. That's it. That's the easiest way to remember this one. You can switch the sign. It doesn't matter what side to what side. Switch the sign. Now we can divide by 3. Since it's a positive number, so you can see that just 1/3 greater than or equal t. So in other words, it says that t is smaller than 1/3. So we can once we get this, and we can completely turn the equation. So what we do, we can write this one exact same one, t less than or equal 1/3. So we can write it like that anytime. You can switch the whole equation around. So remember this one as a shortcut. Like if you have an inequality or equation, you can always turn the whole equation around, but make sure it's also switch because the small side is towards t. So it should be like that. And you can see that the smaller side is towards t. Again, it should be the same way. So this is the other way to solve the problem. So you can solve it in either way. Okay, good. So that's the first condition. So what's the second condition say? What's the domain says? So if you look at the domain says that the t squared plus 4t plus 4 not equal to 0. That's what it says. And then as before, we're going to find the factors. And this case, this is very easy to factor. So this is a complete square. So we're going to get like that. And it's not equal to 0. And then if you take the square root, you can see that t plus 2 not equal to 0. In other words, this is that t not equal to negative 2. So that is the number you have to remove. So that means now we can write the solution, because the one says that t has to be less than or equal 1/3, and this one says t cannot be equal to negative 2. So we're going to put, because it has to have both conditions. There's an and involved here, because both means and. Both means and. So we're going to convert in mathematics, the both, we can convert it to and. So let's try the solution now. So we can say, so thus, the t has to be less than or equal 1/3 and t not equal to negative 2. So the domain equal t such that t not less than or equal 1/3 and we satisfy both, and t not equal to negative 2. So that's how we write it. You have to write and there. It's not a o, it's and. We satisfy both conditions, and means both. So and then if you graph it, it's going to be very simple. So it's a line, and negative 2 is removed. That's negative 2. So we can start with 1/3, that's on this side. So it will be everything below that, but without negative 2. So that means there's a solution. So you can go there and go there. That's a solution. And this is the 1/3 here. That's how we write the solution. And then also, if you write the interval notation, you can write it like this: negative infinity, negative 2, and then union we have -2 1/3. So that's the 1/3 actually is including 1/3, so we can include 1/3 there. So that's the solution. And then you can try these problems as practice problems. So you can also do if the sixth one. There are two expressions, so you want to think about how to combine this. So there's an AND condition coming here. This is the second part of the rational expression video. In this we discuss how to simplify various type of rational expressions. So we start with simplifying rational expressions. To simplify a rational expression, what we do is we cancel the common factors. So we can say simplify by cancelling, simplify by cancelling the common factors. So cancel the common factors. So that's what we do. So let's look at an example. So actually we can write it like this. So we can say if we have a times c divided by b times c, so c is the common factor, so we can cancel it. So once you cancel it, you're going to get the expression a over b. So that is the simple argument. So we can look at an example. Let's say we have x squared minus x minus 12 divided by x squared minus 16, and we know how to factor these kind of expressions in the previous video. So we're going to factor the top. So the factors of the top is you can see x minus 4 and x plus 3, x minus 4 and x plus 3. And from the bottom there's a difference of squares formula because 16 is 4 squared. So you can write this one as x minus 4 and x plus 4 because of the difference of squares formula. If you are not familiar with how to find factors, please look at the video about factoring polynomials, and you can find the link in the description. So now since this is the common factor, we're going to cancel it out. So we're going to get the rest. So x plus 3 over x plus 4. It's very simple, and you can see that we cannot simplify this further than that. And this one is valid only when x not equal to 4. So the assumption here is c cannot be 0. So that means in this case x cannot be 4. Okay, so that's how you simplify these rational expression. So you can try this as a problem. So 3x squared minus x minus 2 divided by 5 minus 4x minus x squared. So you can try this as a practice problem. So let's look at the next type. So next we can talk about algebra of rational expressions. Algebra of rational expressions. So the first and the easiest is the multiplication. So we're going to start with that. So the multiplication. Multiplication. So that means when you have like a times a over b times c over d, so what we can do is we can cancel the common factors if possible and leave the rest as a product or a quotient. So what we're going to do, cancel common factors, cancel common factors, cancel common factors if possible, and leave the rest as a product or quotient. Leave the rest as a product or quotient, depending on what we have. So we're going to cancel common factors and leave the rest as a product or quotient. So let's look at an example. So we can do this one. So we have 2x squared plus x minus 6 divided by x squared plus 4x minus 5 times x cubed minus 3x squared plus 2x divided by 4x squared minus 6x. So what we're going to do, the first step is factor these. So we're going to factor the first one. So the two factors are 2x minus 3 times x plus 2 divided by this one, gonna factor x plus 5 times x minus 1. That's the first one. Second one, you can see that x is a common factor. You're gonna pull the x out. Once you take the x out, you're gonna see that you're gonna get a quadratic. So which has the two factors x minus 2 and x minus 1. The bottom also x is a factor. So once you take x out, you can see that you're gonna get and also 2 is a factor. So you can 2x out, then you can see that you're gonna get 2x minus 3. So you're gonna get 2x minus 3. Now what we're gonna do is you're gonna cancel common factors. So you can see that 2x minus 3 cancels with 2x minus 3. And then you can also see that there's x minus 1. You can cancel. So I'm going to cancel this in a different directions. Then you can see what you cancel. You're going to cancel like that. So that's like a kind of good practice, like cancel different angles. And then you can see that there are no there's x that you can cancel out. So I'm going to cancel x like this, x and x. So those are the only common factor that you can cancel. Now what we can do, we can write the rest. So from the top, you're going to get x plus 4, x plus 2 and x minus 2. So x plus 2 and x minus 2 from the top. From the bottom, you can see that you're going to get 2 times x plus 5. And this is only valid for the term that you cancel out when they are not equal to 0. So that means x cannot be equal to 0. X cannot be equal to 1, and also x cannot be equal to 3 halves. So this is only valid when x not equal to any of those numbers. So that's how you can write the final answer. And you can distribute and write as simple expressions. That's like another option. For example, if you look at the top, you can write this one as, because the different squares, x squared minus 4, and the bottom you can write as 2x plus 10. So that's another way to write the final answer. So any of them are correct. So that's the first type. This is a multiplication. You can see it's very simple. We factor, cancel common factors. Let's look at the next type. Next type is the division. When we have division of fractions, what we normally do is, if we have a over b divided by c over d, what we're going to do is we can write the first one as it is, and then second one we make it a multiplication and flip over. So we're going to c over d over c. So you can see that see this change. So the division became a multiplication and flip the second fraction. So we're gonna look at this example. So we have x3 plus 8 over x squared minus 4 divided by x squared plus x minus 2 divided by 3x minus 6. So by the theory, what we can do, we can write the first one as it is, x cubed plus 8 over x squared minus 4, and then make it a division, a multiplication, and flip over. So it's going to be 3x minus 6 divided by x squared plus x minus 2. Now you can see that this is just a multiplication. That means we can use the steps that we did earlier. So this is a multiplication. Since it's a multiplication, we can just go with the factorization first. So x3 plus 8. This is a cube. So we can do that 8 means 2 to the 3. So this is sum of cubes. And we know how to factor sum of cubes using the formula. The first factor is x plus 2. And the second factor is the complicated one. So that is x squared product with opposite sign, so 2x, and the square of the last term. That's how we use the formula. So we use the formula. We know that if we have a3 plus b3, which is equal to a plus b times a squared, the opposite sign and product, plus b squared. So there's no 2 here. And a similar one works for a minus b. So if you have a3 minus b3, this is a minus b, and then times, is this one, times, so what we have is a squared plus ab plus b squared. So we can use that's what we use for the first term, the second term here. Now for the bottom, there's a different squares that we know, x minus 2, x plus 2 from the different squares, and do the same thing with the other terms. So we can factor 3 out, so it's going to be x minus 2, and then for the bottom, it's going to be x plus 2 and x minus 1. So those are all the complete factorization. And if you are not familiar with how to factor things like that, you can look at the video about factoring polynomials. So we discuss all these types. Now what we're going to do, we're going to cancel common terms, one from numerator, one from denominator. So x plus 2, go with x plus 2, and then x minus 2 cancel x minus 2, and you can see that there are no more common factors. So that means we can leave the rest. So when you have common factors, if you see there are 2 terms in the bottom, you can cancel anyone you like. So for example, we could have also cancelled this one. So it doesn't matter which one. Okay, good. So we write the rest now. So from the top, you get 3 times x squared minus 2x plus 4. And you can see that you can factor the second term. And in the bottom, you have x plus 2 times x minus 1. You can leave in this form, or you can distribute and write the other form, or distributed form. This is up to you. And here this works only when x are not equal to negative 2 or 2, because those are terms that we cancel. Okay, so that's how you do the division problems. So let's talk about adding and subtracting next. For adding and subtracting of fractions, we use a shortcut formula. So the shortcut formula is a over b plus c over d. What we can do, we can multiply like a cross. So we're going to multiply like a cross. That means we're going to get AD plus BC over BD. And you can see that you exactly going to get this formula if you try to take the common denominator. Because for the first one, you have to multiply by D, the top and bottom. And the second one, you have to multiply by B, the top and bottom. That's why you get AD and BC. So we have a similar one for the difference. So when you have A over B minus C over D, this also equal to, you can write this one as AD minus BC over BD. So those are the 2 shortcut formulas. So I'm going to clean this up. So we have this. So those are 2 formulas. This is for the plus. So that means plus go with the plus sign, minus go with the minus sign. That means you don't need to remember both. You only need to remember one of them. so it's just a sum. Okay, so we can also add in. So we can say if it's a minus, it's become a minus. Good. So that's the theory. So let's look at some examples. So you may also, in theory, you may also use the least common denominator. Least common denominator. Least common denominator. When simplifying fractions. When simplifying fractions. So let's look at one example. So let's say we have x over x minus 2 minus 2x minus 1 divided by 3x plus 4. So this is a subtraction problem. So we can use a second version. What we're going to do is we're going to multiply like a cross. So we're going to multiply the cross multiplication. We're going to multiply these two and multiply those two. That means we can write this one as x times 3x plus 4 minus x minus 2 times 2x minus 1 divided by x minus 2 times 3x plus 4. That's the bottom. So what we wrote is AD minus BC divided by BD. So we write AD product and then minus BC product divided by the BD. Good. Now what we can do, we can distribute the top. So if you distribute the top, you're going to get 3x squared plus 4x minus, and then you have here 2x squared minus 5x plus 2. So you can the FOIL to get this answer, and then divided by we can leave it like that, x minus 2 3x plus 4. Now if you simplify the top, you can see 3x squared minus 2x squared, so we have 3x squared minus 2x squared, that means there's going to be x squared. So you can simplify like that. And then if you look at the x terms, you have negative 5x, that means positive 5x, with 4x is going to be 9x, and then the numbers is negative 2 divided by the product in the bottom. You can either write this version or the expanded version. So you're going to get like this, and then you can see that the top you cannot factor anymore. So that means this is the simplified version of this one. So so you can try this one as an practice problem. So x over 2x minus 1 minus 1 over x plus 3. The same argument works. Actually, let's make it a positive one. So you can add them. So same argument works for the plus sign. So it's just you add them. So let's talk about the LCD method. So let's talk about the LCD method. So especially when you have more than two terms, you have to go use the LCD method, because the shortcut method works for 2, and then there are the ISO shortcut method for 3, but it will be much easier to work with the LCD method. So let's look at a problem. So let's say we have 2 over x minus 1 plus 3 over x minus x plus 4 divided by x squared minus 1. And you can see x squared minus 1 has two factors, x minus 1 and x plus 1. So the LCD, the least common denominator, is the product of different factors. The product of different factors are x, x minus 1 and x plus 1. So that's the product of different factors. So this is the product of different factors. Product of different factors. So when you have product of different factors, you're going to create the LCD. Now what we're going to do is we're going to multiply each expression. So we're going to compare the denominator with the LCD, we can compare the denominator with the LCD and multiply by the missing terms. For example, if you look at the first one, the denominator is x minus 1. So what is missing is x and x plus 1. Those two are the missing one. So what we can do, we only multiply the numerator by the missing terms. So that's the kind of shortcut. So that means we multiply 2 by the missing ones. One is x, the other one is x plus 1. So that's what you get from the first term. The second term, x is there. So x minus 1 and x plus 1 is missing. So 3, and then x minus 1, x plus 1. So x minus 1 and x plus 1. And for the last one, you can see that we have x minus 1, x plus 1 is there. So only missing term is x. It's going to be x times x plus 4. It's already there. So that's how you get the numerator. So you just multiply by the missing terms. So you just compare the denominators and look at what is missing from the LCD, and you just multiply the missing term, and then the LCD goes here. So x minus 1, x plus 1. Now what we're going to do, we're going to simplify the top. So we simply distribute. So you're going to get 2x squared plus 2x, and the next one 3 times the product. So you're going to get 3x squared minus 3. The next one is negative x squared, negative 4x. The bottom is still the same, which is x. You can write this one as x squared minus 1. It's the same thing. Now you're going to simplify. So we have, if you look at x squared terms, we get the largest power. These are x squared terms. We have 5 and minus 1, so 4. So it is 4x squared. And similarly, you're going to get 2x minus 4x is minus 2x. And the number is negative 3, and then you can see that there are no more factors, so that means we can leave it like that, because there are no common factors. If there are common factors, you have to cancel, but unfortunately there are no common factors, so we can leave it like this. Good. So you may try this as a practice problem. So it's an exercise. So try to simplify 4 over x minus x plus 5 over x squared minus 4 plus 4 over x plus 2. So you can simplify this one like this. So let's talk about the complex fractions or complicated fractions. So what are the complex fractions? So complex fractions means the numerator or denominator or both are another fraction. So it's a fraction of a fraction is called complex fractions. So we're going to say fractional expressions with, you can say, another fraction with another fraction. It can be both, so it's fractions in the numerator or the denominator, or both in the numerator or denominator, or both is called a complex fractions. It's a fraction of a fraction. So for example, these are complex fractions. So these are a few examples, like 4 over x divided by, let's say, x squared minus 1. So you can say numerator is a fraction, so a fraction of fraction. And another one is, let's say, 1 over x minus 1 over y over x minus y. So this is again a fraction of a fraction. So let's discuss how to simplify things like this. Simplifying complex fractions. So let's look at the first example. So let's say we have 4 over x divided by 12 over x squared. So you can see this is a fraction addition problem. So what we normally do, as we discussed before, we write the first one as it is, and then the division we make it a multiplication, flip over the term. So that means it's going to be x squared over 12. We have to flip over. After that, this is just a fraction multiplication problem. So you're going to cancel the common terms. So 4. So this is 3. This x cancels one of them. So that means you simply end up getting 1x divided by 3. So it's very simple. So let's look at a little complicated one. Let's say we have 1 over x minus 1 over 2 divided by x squared minus 4. So, so this is the major division here. That's the main division. So what we can do, as before, we can write the first one as it is. So 1 over x minus 1 over 2, and we in a parenthesis now, and then make it a division and then flip over. So flip over means because this is the numerator in the major denominator, so it still has to be the major denominator. That means you can think of this one as so divided by 1. So that means if in a flip over, it's going to be 1 over x squared minus 4. You can see that we flip over the fraction, because we have here in the first one we have x squared minus 4 divided by 1. Now we have 1 over x squared minus 4. But you can see that x squared minus 4 is still sitting in the numerator. That's the easy way to think about. Now what we can do, we can simplify the first expression. To do that, this is like a fraction subtraction formula, so we can use a shortcut. So with the cross multiplication, so it's going to be 1 times 2 minus 1 times x divided by the products 2x. So the shortcut times what we can do is we can factor this. So this x minus 2 times x plus 2 by the difference of squares formula. And you still do not see the common factor. So what we're going to do is we're going to flip over, we're going to pull a negative sign out. So that means you can write this one as x minus 2 now. If you pull a negative sign out, and the bottom is 2x. Here we have 1 over x minus 2 times x plus 2. Now you can see that this term get cancelled. So once you cancel that term, that's the only term you can cancel actually. So you're going to get negative sign 1 over, we have 2x here, and then x plus 2. So that is the final answer for this problem. So you can try something like this. So this is an exercise problem. So let's say you have 1 over x minus 1 over 3 divided by let's say 1 over x plus 1 over 9. So let's see how you can simplify something like this. Good. So let's look at another example. As the final topic of this discussion, we can talk about how to simplify different quotients. Different quotients appear in calculus classes when you try to find the slope of a tangent line. So we can talk about some basics about that. So let's say we're gonna get an expression like this. So let's say 1 over x plus h minus 1 over x divided by h. So this is a expression that appears in difference quotient problems. So the question is how to simplify this one. You can see that this is a complex fraction. So what we're gonna do is we're gonna rewrite this one as first we're gonna rewrite the numerator. So it is 1 over x plus h minus 1 over x, and then the division by h you can write as a multiplication of 1 over h. So we can rewrite it like this. And then for the first part we can use the shortcut method. So we can use the shortcut method, like for example, if we have a over b minus c over d, you can write this as ad minus bc over bd. That's a shortcut. So if you use that, so it's gonna act like a cross multiplication. So in this case, we're gonna get x, well, 1 times x minus 1 times x plus h, and then divided by. So we don't need a parenthesis here. So let's write again. So we have x minus x plus h divided by x plus h. So that's what happened to the first term times 1 over h. And then if you distribute, you can see that x and then minus x minus h over x plus h times 1 over h. And you can see that x minus x get cancelled first. So once you do that, you can see you're going to get negative at in front and h over x plus h times 1 over h. Now you can see that you can cancel h and h. So that's the second step. And then you only end up getting negative 1 over x plus h as the final simplified form. So this is how you simplify a fraction like that. So let's look at one more with a square root, because that's very common in different quotient problems. So we have x plus h square root minus square root x divided by h. So when you have square root functions, we have to treat this in a different way. So we can use a special technique called the multiply by conjugate. So we can use the multiply by conjugate method. Multiply by conjugate. So that's the technique we use. So what is the conjugate is, we get a term with the opposite sign. So you see that there's a minus sign. So that means we're going to get a term with a plus sign here. That's what we call the conjugate, the opposite sign. So that means we're going to multiply the top and bottom by that. So we can write this one as x plus h. So we just rewrite this minus square root x divided by h. So we're going to multiply this by a special 1. So what the 1 is the conjugate of that term. So conjugate of this term. So we're going to multiply the top and bottom by that. So that means it is x plus h minus square root x divided by h times, we write the conjugate here, which is x plus h, no change there, but we change the sign here. And then we multiply the top and bottom by that, because this is simply 1 with the exact same term. So now we're going to simplify this. You're going to simplify the top. So you can see there's a special simplification here. So it looks like we have a minus b and a plus b. Those terms are the same. So let's recall what we have. We have a, if you have a minus b times a plus b, we know that by the differential squares formula, this is simply going to be a squared minus b squared. Or if you write with the square root, you can say like this: if you have square root a minus square root b times square root a plus square root b, this you can write as a minus b. So that's much simpler for this one. So that's exactly what we're going to use. That means if you multiply the numerators, what we get is the square of the first term minus the square of the second term divided by h times x plus h plus square root x. And then you can see that when you square root, you simply get x plus h minus x divided by h times x plus h square root plus square root x. I'm writing all these steps here. You can ignore some of the steps. And then you can see now x and x get cancelled. And after that, we're going to get h divided by h times x plus h square root plus square root x. Now what we can do is we can cancel the h term. So that's the second step. And then you simply end up getting x plus h plus square root x, and that is the complete rewriting or simplification of that expression. So you can see that h is now only in the bottom. So this is how you can simplify terms with the square root. Okay, that's about the theory about rational expressions. So now you can try this practice problem for extra knowledge.